Hello everyone, welcome back to the channel. So in the last video, we have analyzed IPL dataset. So we are going to continue the same session from where we left. So before moving further, I just wanted to recap what what we have covered so far. So we just have imported all the required libraries and we just used pd.read method to read the data and df.shape method to get the number of rows and columns and info method to get the details about the each and every column and df.head to get the first 5 rows of the data set and tail is similarly for last 5 rows of the data set. And if I wanted to see any null values present in the data set, just df is null.sum. So you can see the columns with null values. And I also filled all the null values with a 0. Then I checked, then there are no null values found. Then I checked df.head. So it has ended like we have seen some beautiful uh, data like who is the top run scorer from first season to 2023 season end. So that is where we completed and we are going to continue this session with a similar data set. So today we are going to cover and I'm going to show some graphs by using Matplotlib and also by using Seaborn and we are going to explore the data in further. So here you can see I'm just using a histogram to see the same number of runs scored by a batsman. So I'm using SMS data histogram. So this is the code for histogram. So if I wanted to use a line chart or bar chart, so you can replace this hist with a respective graph, whichever you wanted, and you have to mention the column on what column you wanted the graphical representation. Here I wanted to see number of runs from the batsman, and I wanted number of bins to be 30 and KDE is true. And you can see this command plt dot title that could be the title of the graph here where I have mentioned as distribution of runs of the bat and plt dot x label which is runs. So let's run this code. Here you can see that. So in x-axis number of runs, for example, zeros, ones, two, three, four, five, six. So that means like if it is a dot ball and we did not get any runs, batting team did not get any run out of it. So we have around close to 9,800, something like that. We have rows, which is very close to, sorry, it's 1 lakh, not 10,000. I thought it was 10,000, but it is close to 1 lakh. So if you compare with all other run types, so there are more dot balls. We have around closely 1 lakh dot balls. So if I see the data set, okay, so you can see out of 2,43,815 rows, I have around 1 lakh dot balls. And if you see single runs, one means it's a single run. So we have second most runs, singles, which is also close to 90,000 runs from the singles. And doubles are like around, I think I can say it is 16,000. Then obviously there are very few runs, 3 runs we got from a single ball. So fours are again maximum. More than 20,000 runs are scored by fours and five and sixes also we have around I think 6,000 closely. So this is the distribution of runs of the bat. For example, uh, So you can see the graph, like how many runs we got, how many dot balls are there, how many single runs, double runs, how many fours, how many sixes. So this distribution shows the number of runs from the bat. Now I just wanted to see the number of extra runs. Like here, the number of runs from the bat. And so we have a combination of number of runs from the bat and extras like white balls, no balls, buys, leg buys, and if there are any penalties, so we can consider those as extra runs only. So I'm creating a separate parameter called extras. Then I'm including all extra extras like white balls, no balls, buys, leg buys, penalties, and dot sum. So this equation will give me all the extra runs stored in the dataset. Then uh, I'm going to plot a bar graph. So it will give me like out of five categories, how many white balls are there, how many no balls are there, how many buys are there, how many leg buys, how many penalties. The sum of all whites out of all, like for example, from 2009 to 2023, how many balls are bowled. So again, if I wanted to put a title to the graph here, so like this, here I mentioned as distribution of runs of the bat. So here, since I'm talking about extras, then I put number of extras by type. What is the type? And the X label is like X-axis, extra type, and Y label is for number of white balls or numbers. It will show the sum of the white balls or sum of no balls. So let me run this code. Here you can see it clearly. Like so, you can see out of you can see the number of whites here. Number of whites are more than it is close to 10,000 white balls have been bowled from 2009 to 2023. And there are a few no balls. It is around 1,000 no balls, and these are buys and these are leg buys. And obviously, we cannot see much penalties until and unless there could be a mistake from the bowling team. Penalty runs are very less. So you can see white balls. Extras in extras, we have almost 10,000, close to 10,000 white balls. So this is how you can plot number of runs from a bat and number of extras given by the bowling team. So so now I wanted to see the total runs from the from a ball bowled. It could be from the bat or it could be an extra. So I have created a separate column called total runs. So this is combination of number of runs plus number of extras. So now you can see the data set head. Now a new column will be added at the end. So you can see it was not there. Previously we had only 23 columns. Now a column has been added. And if you can see the shape also, you can see the extra column, 24th column. So it is like I just summed number of runs from a bat and number of extras. You can see like here we do not have any runs out of ball and it is not an extra also 0 0. So here we have a single run, then plus 0, it is 1. So it will add these two columns, number of runs of the bat plus extra runs. So that is what we can create a new column with existing column. Okay, now we were talking about number of runs scored by a batsman. So let's look at the bowling side as well. So I just wanted to see the type of wickets. So there are different columns under wickets. It could be a catch out or it could be a bowled LBW, catch and bowled and stumped. So I am assigning to a new variable called wicket types. All these variables are different categories, and I'm just filtering from the dataset called wicket type because my wicket type column has these different categories. I'm just I just I have taken this data from the dataset only, but I've assigned this list to a new variable and I'm checking if it is there, filter it. So wicket type dot is in wicket type of interest. So if it is there, then it will be assigned to filtered wickets. Then wickets by bowler. Filter wickets dot group by the bowler name. Under bowler column, we can have the name of the bowler dot size and the top wicket taker. So previously in the previous analysis, we are analyzed how many runs scored by a batsman. Here now analyzing or extracting the data uh, top bowler wise, how many wickets a bowler has taken, and from I'm sorting from descending order, top to bottom. I just wanted only 10 rows because there are hundreds of records because there are thousands. I could say out of 17 seasons, you could see thousands of bowlers have bowled, and at least one of them has taken one wicket in instances. So we don't need one wicket or two wicket. I just wanted to see top 10 wicket takers from first season to 2023. And I'm just printing top wicket taker and I'm just assigning this inside the print. So let's run this. Now I have the data. So Yuzvendra Chahal has taken 187 wickets, followed by Bravo, followed by Chawla. So you can see there is an increase in the number of wickets taken by Chahal since in 2024 season data is not added here. So it could be more than 200, but this data is as of 2023. And for Mishra it is 173 and Ashwin it is 171, Malinga 170 and the list goes on. So this is how you can get the number of top wicket takers from the first season to 2023 season. Okay, now I wanted to plot the above data, like bowler wise, how many wickets has taken, like how we plotted for number of runs scored. So here I just wanted to plot a bar chart. So again, PLT dot figure fixed size. So I have imported Matplotlib as PLT, right? So that is why the command starts with PLT dot figure and inside. So I'm just assigning a size of the data, like a size of the graph. I wanted 12 by 8. 12 means for x-axis, 8 for y-axis, 12 by 8. And I'm plotting this plot using SNS, Seaborn bar plot. I'm using the bar plot and here you need to give what kind of values you wanted on x-axis and you must assign x and y values. Whenever you are plotting a bar chart, you must mention what is y, what is x and palette. So here I wanted top wicket taker dot values. Here I have the top wicket takers value. You can see it is mentioned above top wicket takers. I have top 10 bowlers. I'm assigning top wicket taker values to the x-axis and top wicket taker dot index to the y-axis and palette is some colors I'm assigning. So I'm applying a for loop for I in range length of wicket taker. For example, first it will go to the first value, then it will go to Bravo. Axis chart text top wicket taker value is 1. First value it will go to Chahal plus 1. Then second time it will goes on till it will end till the last bowler. Again, I'm assigning a title and I'm assigning X label and Y label. So let me run this code. Now you can see. So just a graphical representation of the above data. So here also you can see by looking at the data, you can see how many wickets has taken Mr. Chahal. So it is a simple graphical representation. It looks nice, right? So whenever we are presenting any data with a graph, it looks really nice. So Chahal is 187, DJ Bravo 183, Chawla 179. It goes on till Harbhajan Singh 149. So this is how you can plot nice Seaborn and Matplotlib graphs. Okay, so this is what data set of IPL. So we have explored everything from the data set. So if I wanted to explore everything team wise and venue wise, it will take a lot of time. So that is why I just taken batsman wise, top run scorer and top wicket taker. And also I'm trying to plot the graphs, trying to show the data by using Matplotlib and Seaborn. So I hope you guys are enjoyed with the first series. So I hope you will enjoy this video as well, since it could be some colorful data. We have ball to ball, extra runs, and the runs distribution with the ball to ball data. So, so that is what I have for this data set. So in coming days, I will come up with different interesting data sets, and I'm going to analyze different aspects of the data, and I'll try to show the data distribution. I hope you guys are liking these videos. So please subscribe the channel, and if you have any questions, you can always comment. Thanks everyone. Bye.